All right, so in my last video, part 2 of this series, we were doing function compositions and we're working on the classwork. So we did 4, 5, and 6, and now I want to do the last 4 in that section, 7, 8, 9, and 10. So let's look on the next slide. And what we're going to do is we're going to keep the same functions we've been using. F of x is still going to be equal to 4x. And my function g of x, which is a little bit different, that's going to still be equal to x squared. So number 7 says we need to find f of f. F of f. And we're going to evaluate it at x. So what does this mean? This means that we're composing f with itself. We're using the function f twice. So usually when we do compositions, the function on the left, I write down first, and then the function on the right side, I write down second on the inside. And then I'm going to close up my 2 sets of parentheses. So what I'm actually doing is I'm taking the function f of x and I'm putting it inside of f of x. So it's kind of like an iterated function. All right, so what is f of x? Well, we defined f of x, right? F of x is up here. It's equal to 4x. So we're going to put a 4x where that f of x is. Okay? So all I've done so far is I've replaced the f of x on the inside with a 4x. And I'm allowed to do that because they are the exact same thing. So now I need to take the function f of x and I need to evaluate it at 4x. What that means is every single x in the function f, I'm going to replace with a 4x. Every single x I see right here, I'm going to replace it with a 4x. So instead of the x right here beside the 4, I'm going to put a 4x instead. So now I have 4 times 4x, and that's going to give me 16x. And that's my answer. All right, so that we call our composite function, or our function composition. Now for number 8, it's asking us a question that's a little bit different. It's saying, take f of f that you just found, but evaluate it at 1/4. So what we're going to do is we're going to take that 16x that we just found and we're going to replace that x with a 1/4 and see what happens. So I'm going to take that function and I'm going to keep the 16 the same, but I'm going to replace x with a 1/4. What that means is I get 16 times 1/4, which is just going to be 4. And I'm done. So when you evaluate a function at a number, you're going to get a number in return. Okay, let's try number 9. Number 9. And let me separate all this out. There we go. So what does number 9 say? It says find g of g evaluated at x. Okay, so what this means is I'm going to have g of x. So I'm taking the function g of x and I'm putting it inside of itself, right? G of x. So what is g of x? Well, we know that g of x is the same thing as x squared. So I'm going to replace the g of x on the inside with an x squared and see what happens. So now I'm going to evaluate the function g at x squared. What that means is everywhere I see an x in the function g, I'm going to replace it with an x squared. So I'm still going to have something squared, but on the inside, I'm going to put x squared. Okay, So now I have x squared squared. And if you know anything about exponent rules, once you square something, you're multiplying the exponent by 2. So 2 times 2, when I multiply the two exponents together, I get 4. So my answer is going to be x to the 4th power. All right. The last one we're going to do in this video is going to be g of g, but we're going to evaluate it at -3. So I'm going to take that function that we just found, that x to the 4th power, and I'm going to replace x with a -3 and see what happens. So the x is going to be a -3. I'll put that in parentheses because it has a negative, right? -3 to the 4th power. So what is -3 to the 4th power? That's going to be a positive 81. Now, the reason behind that is because you have -3 being multiplied by itself, and you're going to have 4 of them in a row, right? That's what the exponent of 4 means. So I've got the first 2 that multiply, and they're going to give me a positive 9, right? -3 times -3. Well, the next pair is also going to give me a positive 9. And then 9 times 9 is going to give me that 81 that I need. Okay? So those are the last 4 questions that I'm going to do in this video. And I hope that makes sense. This is function compositions, and I'll be coming out with more videos in the future. Thanks for watching, and I hope this helped.